We're going to be using the exact same concepts we talked about yesterday: supplementary angles, vertical angles, and complementary angle relationships. And we're going to take it a small step further. Instead of just having a missing variable like we saw B on last night's worksheet, instead of just having a missing variable, we're now going to have an entire expression. It's going to look a little bit scary, but again, if you remember our equation solving unit from the end of term 2, this is going to be a breeze. And I would highly recommend you don't forget your equation solving, because you're going to need it in every math class from here on out for the next 4+ years if you want to keep doing that. So, can I get someone to read this little italic sentence right here real quick for a rich ticket to find? Victor, go for it.
To find the missing variable and give an angle relationship as discussed in 3 questions.
Perfect. And then, Victor, go ahead and read those 3 questions out for everyone.
What type of relationship am I looking for? See note 1. What 2 equations am I going to add together? What do I set the equation to? What do I set the equation equal to?
Equal to. Perfect. Thank you, Victor. So we get a problem like example A or a problem like example B, right? All we have to do is ask ourselves 3 questions. They're right here in this box. It's nice and easy. It's printed for us, so we don't have to, look for it or write it down. It's right here. The first thing is, what type of relationship am I looking at? Again, remember, a relationship is not acute, obtuse, right, and straight. A relationship is like complementary, supplementary, vertical, and those are the only 3 we're going to work with today. The second question we ask is, what 2 quantities am I going to add together? Now, this isn't going to apply if we have vertical angles, because they'll just be equal, but we'll get to that in another example. And once you know what 2 quantities you're adding together, you're going to ask yourself, what do I set this equation equal to? Luckily, there's only 2 options, right? It's either going to be equal to 90 or equal to 180, right? For complementary and supplementary. So go ahead and add that in there. Boom. Very simple. 3 questions. Not super, philosophical, crazy questions. They're pretty straightforward. So let's just jump right into example A and see if we can answer these 3 questions all on our own. Number 1, what type of relationship am I looking at? Take a couple moments to think about it. It shouldn't take too long. But everybody all together tell me, what type of relationship do we have here in example A? Go. Okay, let's try that again. Let's try and get as many people as possible to say what relationship we have here in example A. Everyone go ahead. There we go. Look at that. That was beautiful. Complementary, right? Who can tell me, how do we know these are complementary, Noah?
It's a 90-degree angle.
Exactly, because they form that nice 90-degree angle there. So the answer to number 1, what relationship are we looking at? Our answer is going to be complementary. It's really important that we understand what relationship that we have, because that's going to help us answer questions 2 and 3. Gentlemen, stop. It's going to help us answer questions 2 and 3. Let's go to question 2. So if these two angles here, if they form a complementary relationship, right? What 2 quantities am I going to add together? Well, we're just going to take the 2 quantities that we're given. This question is kind of not really a necessary question when we think about it, because there's only 2 quantities here, 4x and 42. Right? So we're going to add together 4x plus 42. Why are we going to add them together? Well, we know that whatever number... Say that one more time. Yeah, because they're 2 different quantities. So we have to add them together to get 90. That's exactly what the definition of a complementary relationship is. So number 3 should be pretty simple now that we've answered number 1. What am I going to set this equation equal to if we have a complementary relationship? 90, right? 90. It's the same exact thing as yesterday when we had B plus 42 equals 90, except now we're going to have to do one additional step. Let's go ahead and set this equation up here. 4x plus 42 equals 90. Yeah, sure. Any questions on how we set this equation up? Where we got these numbers from? Good. Now, let's go ahead and think back to our equation solving. What's the very, very, very first thing that we want to do? Ooh. We remember. Even before we subtract. Ah, there we go. We're going to draw the line down our equal sign. Exactly. We want to split our equation in two sides, the left side and the right side, so that we know that we're subtracting in the right way. Just like Theo said, the first thing that we need to do now that we've drawn our line, is what again? Say it again, Theo. Subtract what from what?
42 from one side.
That's right. We're going to subtract 42 from 90, and we're going to subtract 42 from 42. Because what we do to one side, we always have to do to the other side. 42 minus 42 cancels out, leaving us with just 4x on the left. And then what's 90 minus 42 going to give us on the right? 48. 48. Perfect. Thank you. 48. These aren't even the crazy equations, like when we had to fraction bust and distribute and do all that nonsense. These are nice, simple, just two-step equations. What's my last step here going to be? If 4x is equal to 48, that's right. Thank you, Blake. We're going to divide both sides by 4. How did we come up with division? Well, remember, we want to ask ourselves, what am I doing to my variable right now? With 4x, what are we doing to our variable? Close. We're multiplying, right? 4 times x. So if we want to do the inverse of multiplying by 4, we've got to divide by 4. 4 over 4 cancels out to just 1, leaving us with x equals 48 divided by 4, everybody? Or anybody? 12, exactly. Now, here's an interesting question. Is our answer going to be 12 degrees? No. Why not? Why is our answer not 12 degrees? Theo, help us out. Why is it not degrees for our answer? Okay, that's all right. I appreciate your honesty. No, why don't we need degrees on our answer?
Why don't we need degrees?
Yeah, why don't we put degrees here?
Oh, it's because 12 and 42 don't equal 90.
12 and 42 don't equal 90. Okay, interesting thinking. I see what you mean by that. Right? Let's try Hannah.
12 is the variable?
Exactly. 12 is the variable. 48 is the actual angle measure here, right? 48 and 42 makes 90. So no, you were definitely on the right track, right? You noticed, hey, 12 and 42, that wouldn't make sense because 12 is not the angle measure, it's the missing variable, right? So if we plugged it into 4x, this angle would be 48 degrees. So we don't need to put degrees on our answer when we're solving for that missing variable like we just did. I appreciate everyone participating in that discussion. How do we feel about this? Where are we at mentally? Show thumbs real quick, just so I can get an idea. Good. I see some sideways. That's perfect. Okay. All right. Let's flip over to supplementary because it might make some more sense if we see another example. Noah? Yeah. Sure. Go ahead. So, example B. What type of relationship do we have here now? I already said it, but supplementary, right? How do we know, again, that these are supplementary angles? Because Mr. Church told us. Close. Very close. Because they add up to 180. If we draw our little angle markers, there's my first angle. There's my second angle. All together, that creates a nice straight line. Or a straight angle. I keep saying straight line. right? So this whole measure here, both combined, is going to give us 180 degrees. We know that right off the bat. So we can answer number 3. What are we going to set this equation equal to? If it's supplementary, what do we set it equal to? 180. And what two quantities are we going to add together? Parentheses x minus 20 and? Oh, degrees, yep. And what are we going to add to that? 150, exactly. 150 degrees. Now this one's a little bit different, right? Because we have more than one term in our first angle. We've got x minus 20. But we're going to solve this in the same exact way. Let's go ahead and set it up. X minus 20. We don't even really need the parentheses, so let's drop them. X minus 20 plus 150 is equal to 180. Take a look at where we got these quantities, how we set them up, and make sure you understand why we plugged them in this way. If you're not too sure how we came up with this, let me know either now or when we get to work, and I can help you out. So we take a look at this equation, x minus 20 plus 150 equals 180. I'm going to split it down the equal sign, just like all of our multi-step equations. But in this problem, what do we need to do first? It's a little bit different than the previous one. But what do we notice we need to do here on the left-hand side, Jordan?
Add 20 to both sides.
We could do that. We could do that. That would absolutely give us an answer that we want. But what can we do just on the left side, Jordan? I know you see it now. That's all right. Azalea, help us out. Combine like terms, exactly. We've got two constants here on the same side. I know it's been a while since we've talked about this, so totally understand. I appreciate it, Jordan. It's been a while, so we're going to combine like terms. And what that looks like, again, is we just take negative 20 and positive 150. I'm going to write combine like terms here. And let's just simplify what that would be. What would negative 20 plus 150 give us?
130.
130, exactly. We can think of it like 150 minus 20. So now we have x plus 130 equals 180. Now what can we do on both sides? We're going to subtract. What are we going to subtract on both sides? 130. Again, we're adding 130 to our variable, so we want to do the opposite of that, which is subtracting 130 from our variable. The 130s cancel out, leaving us with x is equal to what? 180 minus 130? 50. Perfect. Is it 50 degrees? No, it's not. It's just x equals 50 because we found the missing variable. But if we wanted to find what that actual angle is, what are we going to have to do to it? Subtract 20, right? This angle here is x minus 20. Well, if x is 50, then this angle is 30 degrees. 30 plus 150 equals 180, right? Some of you may have caught on to a different way that we could have done this, and that's great. If you understand that way, please do it that way. That's fine. But I want to take a look at what Jordan mentioned, because it brings up a good point. What if we didn't think to combine like terms, right? We don't always know exactly what to do, and that's fine. No one should be expected to always know exactly what to do. So let's just work it out and see if Jordan's way would have worked. X minus 20 plus 150 equals 180. Jordan said, I'm going to add 20 to both sides. That sounds good to me. Plus 20, plus 20. What do we get on the right? 180 plus 20? 200, right? Perfect. X plus 150 equals 200. Now what are we going to do on both sides? Subtract 150. And 200 minus 150 gives us what? 50. Is that the answer we got doing it the other way? Yes, it is. We got the same exact answer. So, Jordan, you were definitely right. But I did just want to remind us that combining like terms is technically what we're supposed to do first. But you would have got it right either way. So, great job. That's what I meant when I said if you saw a different way to do it, you can definitely do it this way too.